So today is day one of probability. The definition, or one way to say what a probability is how likely an event is to occur. How likely an event is to occur. You deal with probability almost every day when you check the weather. The weather is usually a prediction. It's usually a probability. There's a 60% chance it will rain today. You don't check the weather? Well, a lot of people do check the weather. Is that what you're saying? You only live once. Who checks the weather? All right. Sample space. This may or may not be a new word for you. It's the set of all possible outcomes. The set of all possible outcomes. And we'll be talking a little bit about what a set is later. We won't go as into detail as they did in my college class when I had an entire class on set theory. Super fun. Super math nerd fun. But we will touch a little bit on what a set is. Set of all possible outcomes. So let's talk about the warm-up today. The probability of our warm-up was 4 out of 9, right? That's what we came up with. 4 out of 9, yep. What was our sample space in our warm-up? Well, our sample space, there were 18 items in our sample space. And our sample space was every student that was signed into our class right then. So this people signed in, you were our sample space. And there were 18 items in the sample space. Let's look at this one. You don't need to write this part down. This you can just watch. So we can write probabilities as, we did this in the warm-up. We can write them as a fraction. We can write them as a decimal. Or we can write them as a percent. So you need to be able to go back and forth between these 3 different ways that we can write probabilities. Now, if it is a fraction, let's talk about what the range is. If you say that the probability is 0, what are you communicating? What does that mean? So like if I put all your names in a hat and I said, what's the probability that I draw a student from Louisiana out of this hat? And if none of you are in Louisiana right now, but if no one was from Louisiana, that means I couldn't do it. It is impossible. It has a 0 chance of happening. So that would be 0. Now, what's the probability? What does it mean when a probability is 1? So that would be me saying, hey, I put all your names in a hat. What's the probability I draw a student out of here that's in geometry? Well, all the students in my hat are in geometry. That would have been 18 out of 18, which we know, of course, is 1. So if you're writing probability as a fraction, it can range from 0 to 1, where 0 is impossible and 1 is certain. The opposite of impossible, right? Now, if you write it as percents, of course, you could range from 0 to 100. There's no such thing as, oh, it's 110% likely that it will rain tomorrow. That doesn't make sense, and it's not a thing. It's not a thing. Okay, here we go. Let's do a few examples. If I roll a number cube, which they call dice a number cube, by the way. That's what they're going to call the dice. If I roll a number cube, what is my sample space? Remember, sample space is the set of all possible outcomes. So the sample space is 1, or 2, or 3, or 4, or 5, or 6. The sample space is where you list the possibilities. Now, how many items are in the sample space? There's 6 items, but you wouldn't say the sample space is 6. The sample space is 1, 2, 3, 4, 5, 6. The number of items in the sample space is 6. All right, spinning a spinner. In this spinner, which is not too exciting, what is the sample space? Red, blue, green, yellow. How many events, how many items are in the sample space? Sorry. There are 4 items in the sample space, but the sample space is red, blue, green, yellow. All right, write down this. This would go in your notes. Theoretical probability. So what does all this nonsense mean up here? What do all these symbols mean? The probability of A. So your event is A. What you want to happen, or your event is A. The probability of A happening, you put the favorable items over the total items. You put the favorable items over the total items. This over here stands for you put the number of items in set A divided by the number of items in the sample space. So that in parentheses S means the number of items in the sample space. So in our warm-up today, the number of items in our sample space was 18. 18 was N of S, which is not, it's not important that you memorize the formula per se, is just the concept. The number of items in our event, we wanted to choose a boy. And so how many boys were there in our class? So there were 8 things that were favorable. There were 8 items in event A. And then there were 18 items total in the sample space. So that's how we got our probability from the warm-up. Cool? Let's try some examples. Each letter of the word probable is written on a separate card. The cards are placed face down and mixed up. What is the probability that a randomly selected card has a consonant? So this is us doing theoretical probability. We are not actually conducting an experiment, although we could. We could put the letters on some note cards and we could draw and see what happens. But we want to know what is supposed to happen, what theory says is supposed to happen. So we're doing theoretical probability, not experimental. Well, first we might need to know what a consonant is, right? That would help. What's a consonant? Everything that's not a vowel, Miss Tanton, right? Yeah, okay. So it's all the letters except for A, E, I, O, U. Okay, Y is not an issue here, right? Because it's not in the word probable. So we want to put the number of items in our event over the number of items in the sample space. How many items are in the sample space? This is just a fancy way of saying, how many choices do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 is the total. Probable, or what? Favorable, sorry, favorable over total. Favorable over total. All right, how many are favorable? Consonant, 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 consonant. 5 items are favorable. 5 items are in set A, and 8 items are total. All right, let's get in the practice of writing it 3 ways, just for the first few ones. So the probability is 5 out of 8 times you will get a consonant. That is 0.625 as a decimal, and you multiply by 100. About 62.5% of the time we will get a consonant, or 63% chance. Very good. Next one. 2 number cubes / dice are rolled. What is the probability that the difference between the 2 numbers is 4? I'm going to give you all some time to think about this. But what I'm going to do while I give you time is give you this visual aid that will help you picture what your choices are. Okay? Okay, I always start with the denominator. I think it's always the easiest to figure out what the total is, what the sample space is. So, what is the total number of outcomes that could happen when I roll 2 die? Good, 36. One way we could look at it is this is 1 through 6. There's 6 items here. And then on this side of the table, 1 through 6. So 6 times 6 is 36. You could also say on dice number 1, I have 6 choices. On dice number 2, I have 6 choices. So you could multiply those as well. Those are different ways that we could get the number of items in our sample space. There are 36 different choices. Now we need to figure out how many of those are favorable. Favorable over total. Name a combo that would be favorable. Name just one. What's a combination of numbers that would be favorable? 5 and 1. Good. Now 1 and 5 and 5 and 1 would both be favorable. So now we have 2 items in our favorable set. And good. 6 and 2. 6 and 2. 6 and 2. What else? That's all, folks, right? The probability that the difference is 4. The probability that the difference is 4. Those are the only numbers. You're like, oh, 7 and 3. Oh, wait, there isn't a 7 on the number die. So anyways, 5 and 1, 1 and 5, 2 and 6, 6 and 2 are the favorable outcomes. So favorable over total. 4 out of 36. 1 out of 9. Miss Tanton, do I have to reduce my answer? Yes. Always, every time we reduce our answers. Yes, yes, yes. Let's write it as a decimal. And, of course, as a percent. There is an 11% chance, a pretty small chance, that the difference between the numbers is 4. Okay. Okay, here's the set theory part, my favorite part. This is the sophisticated mathematical part. Please write these down in your notes as I talk about them. So when you have sets, these sets can intersect, or we can talk about the union of these sets. And those are two totally different things, so let's look at that. When you're having two sets that intersect, you are looking at the set of elements that are in A and in B. And is a key word there. So it would be the elements that are in both A and B at the same time. It's going to be a smaller set that we're looking at. The symbol for intersection is an upside down U, or some people like to say it looks like an N, like a horseshoe. It's A intersect B, where this symbol means intersect. A intersect B. Confederates and Union. History is so much applied to this. Okay, cool. All right. A union, the key word in union is or. I want everything that's in A or B. You're not as picky if you're a union. You just want it all. I want everything in A and everything in B. So this one's easy. A union B, it looks like a U. A union B. That's the symbol for union. So we've got the symbol for intersect and the symbol for union. And they are just 180 degree rotated of that one symbol, right? Cool. All right, so keywords. And versus or. Big time. Keywords. And versus or. Intersection is and union is or. This symbol is, do it in backwards. This symbol is and this symbol is or. All right. One more word to put in your notes, a complement. This one is complement. Yes, it's spelled differently than like when you pay someone a compliment, right? A complement is all the elements not in A. You never thought about that. You can shade inside A, you can shade inside B, you can shade inside their overlap, but did you think about shading outside of the circle? So that's what this is. And the symbol is A superscript C. So the complement of a set is I want everything not in set A. So the key word for complement is not. In our warm-up today, we said, what's the probability we draw a boy's name? The complement of our probability was drawing a girl's name. It's everything that's not favorable. Sorry, girls, you weren't favorable in the warm-up, but you were the complement, so maybe that could be a nice thing. So what's important is this formula right here. In the warm-up, our probability was 4 out of 9. That was the probability of event A. But if I wanted the complement of A, I know I want everything except A. And I know that the highest my probability can be is 1. So I want everything that I can squeeze out except for 4 out of 9. So when you're finding the complement of an event, you simply take the probability that it does happen and you subtract it from 1. And that's the probability that it does not happen. So that's how you compute the complement. You find the probability it happens and you subtract it from 1. 1 minus the probability of A. Yeah. It's like non-coplanar. Look at all these analogies y'all are coming up with. I love it. Good connections. Okay. let's try it out, guys. Whoa, here we go. You roll a number cube. Event A is rolling a prime number. Event B is rolling an even number. You do not have to draw a Venn diagram on all of these. You do not. But let's just draw a diagram to see what it would look like. All right. Event A is rolling a prime number. What numbers are prime? You have to know your number theory, huh? 2, 3, and 5. Very good. 2, 3, 5. All right. Check. Got you. Event B is rolling an even number. Oh, 2, 4, 6. So wait a minute. I'm going to take that away because 2 is in both set A and B. And then we've got 3 and 5 in just set A and 4 and 6 in just set B. Any questions about the Venn diagram here? Any questions about the Venn diagram? All right, let's solve some problems. The probability that A happens. Now, how many events are in our sample set? We're just rolling one dice. Sample space. How many events are in our sample space? There are 6 events. And how many are favorable? How many are in circle A? 3. 3 out of 6. So the probability that we roll a prime number is 1 out of 2, 1/2. Okay, what about B? There are 6 events. Actually, 6 is going to be our sample space for the whole problem, so we don't worry about changing that. How many are favorable for event B? Well, there's 3 even numbers, so this is the same answer both times. So the probability that we roll a prime and the probability that we roll an even are the same probability. Okay, here's where we use our new stuff. A union B. Look at your notes. A union B. That means or. I want everything that's in A or B. I want it all. So how many are in either A or B? 1, 2, 3, 4, 5. There's 5 events that are hanging out in either A or B. Union means union them. Take them all. Okay, intersection. Intersection is where event A and event B overlap. There is only one item in the intersection of A and B. Not bad, huh? The probability of the complement of A. So the probability of the complement of A is, I'm actually going to erase these. It's 1 minus the probability that A happens. And that one's not very interesting because 1 minus 1/2 puts us at 1/2 again. It's not very interesting. The next one will be. Probability of the complement of B, well, B was 1/2, so you subtract it from 1 and you end up with 1/2 again. All right? Okay. Let's try another one. Your grocery basket contains 1 bag of each of the following items. You're getting ready to transfer your items to your cart from the cart to the conveyor belt. Event A is picking a vegetable first. Event B is picking a green food first. Dun, dun, dun. Okay, I'm going to let you try it for a couple minutes. Let's look at our shopping basket. We are quite a healthy shopper this week. We want to know, event A is picking a vegetable. This time I'm not going to make a Venn diagram. I kind of want you to see it both ways. I want to pick a vegetable, so I'll go through and circle everything that is a vegetable. Vegetable, vegetable, vegetable. How many items are in our sample space? So the number of items in our sample space is 8, right? So the probability I pick a vegetable, favorable over total, 3 out of 8. All right. Now, event B is picking something, well, let me get my green out. Picking something that is green. So now I'm going to underline everything that's green. I'm not going to circle it. I'm going to underline it so that I can see the difference. Did I miss anything? It looks like there are 4 green items out of 8. So the probability of grabbing something green would be 1/2. All right. Next up, the probability of A union B. That's A or B. So you pick everything that's either underlined or circled. Underlined or circled. 1, 2, 3, 4, 5, 6 out of 8. Never leave it as 6 out of 8. You have a 3 in 4 chance of choosing a vegetable or something green. Okay. Next one. Probability of A intersect B. What is both circled and underlined? Circled and underlined. Oh, the only one is spinach. That's a superfood, isn't it? That's really, really, really healthy. All right, so 1 out of 8 for the intersection. How are we doing so far? Everyone on board? We okay? The complement of A. We learned that the complement of A is 1 minus the probability that A happens. Your calculator can do it, or you can do that in your head. It's like saying 8 out of 8 minus 3 out of 8. So you're just doing 8 minus 3 to get your numerator there. Complement of B, 1 minus the probability of B happening. So for those last two, you're already using something you found, and you're just subtracting it from 1. Okay. Last problem of the day. I know time's running out, so let's just do it right ahead. Start right now. A lot of questions you're going to be asked about are about cards, so I want to make sure you know what's in a deck of cards, okay? So there's 4 different suits, there's 2 different colors, and the numbers go from A to K. Ace is like 1, and then it goes all the way to king. Jack, queen, king are like 11, 12, 13. What's the probability that you do not choose a king? When you see the word not, it's a complement problem. Now, you don't have to use complement to solve it, but I really do recommend that you do. So I want the probability that I choose a king. Oh, well, that's easy. 4 out of 52 cards in a deck. We do not count the jokers, by the way. So the probability I choose a king is, reduce it, 1 out of 13. I want the probability I do not choose a king. So I do 1 minus the probability of choosing a king, and I get 12 out of 13. A 12 out of 13 chance that I grab a card and it's not a king. What's the probability you choose a black 5? This is almost like an intersection problem, right? It's like probability of black intersect probability of 5, I guess, because it has to be both. Anyways, I'm just trying to relate it to the lesson. How many black 5s are there? That's all it comes down to. There's 2 black 5s, and there are 52 cards. So a very small chance, a 1 in 26 chance that you choose a black 5.